Hello everyone, I am Emil Vindas and I'm going to present a brief overview of our work about hybrid models for medical signal classification. This work was done with Kevin Yepier, Marie-Lise Almar, Emmanuel Roux, and Philippe Blachard. So what is our main motivation? What we want to study are cerebral emboli. Cerebral emboli are gaseous or solid particles that can circulate in the cerebral bloodstream. They can cause stroke by blocking a cerebral artery. This emboli can be caused by different sources, such as athermatous plaques due to carotid stenosis, or some surgical procedures, such as transcatheter aortic valve implantation. To detect emboli, different devices can be used, but we are going to focus on transcranial Doppler devices, which allow a long duration monitoring of the patient and which are going to generate, at the end of the recording, temporal dependent signals. So what are the main challenges? As I said before, we are going to work with temporal dependent signals. This is a common problematic in the medical field because there are a lot of monitoring devices such as transcranial Doppler or electrocardiogram that can generate temporal dependent signals. So we are going to have one input modality, the signal, but we can have different representations of this modality. And these different representations can have complementary information. So the question at the end is which representation is the more adapted to our task and how can we combine these different representations to solve our task. So to do this, we propose to use an hybrid CNN transformer model, which is capable to exploiting directly the raw signal, but also to use the spectral context thanks to a time frequency representation. So to do this, we are going to use two independent classifiers, and we are going to combine the output of these classifiers using some late attention fusion weights, which can be interpretable with respect to each input representation and with respect to the final decision of the model. So to evaluate our method, we use three datasets, one TCD dataset, transcranial Doppler dataset, and two publicly available electrocardiogram datasets. Here we can see the main results of our work, and what we can see is that our proposed method always outperforms the single representation baseline. Moreover, we can see that we have more stable models as we reduce the variability of the classification performances of the model when we use different representations. And finally, we achieve state-of-the-art performances on two of the three datasets. In this last slide, what we can see is the late fusion attention weights for the different datasets. And what it is interesting to see here is that depending on the class and depending on the dataset, the input representation that is the most important to the final decision of the model can change. Thank you for your attention, and if you have some questions, you can come see us at the poster session.